Hello and welcome to the TEXTEQU YouTube channel. This is the assembly language series specifically for MASM, x86, and 32-bit mode. We will be focusing on implementation details rather than some of the finer points of discussion. If you're looking for more informative discussion on some of the different topics that we're going to be looking at, definitely go ahead and do some YouTube searches or look at some articles online. In the future, we're going to be putting more videos up that'll give you a little bit more in-depth look into why some of these things are used the way they're used. But as of right now, we're just going to be doing implementation specifically, so that way people can have a better idea as to how to implement in the x86 MASM language as for assembly language. And so that's pretty much going to be our focus. In the future, like I said, we will have other videos that will go more in depth, but if you like this, please feel free to share with anybody that you find might benefit from this. And don't forget to check us out at TEXTEQU.com. Enjoy. Okay, so welcome to the very first lesson in the series. We're going to be talking over integer literals, reserved words, segments, labels, comments, defining variables by size, and the TEXTEQU directive. As you can see, I've kind of already started here. I've got some of this set up. If you're not familiar with Irvine Library, Google Irvine for assembly language, MASM, and you'll see the website there. Just follow the link, follow his directions on there, install the program appropriately, and it's pretty simple. If there's a lot of questions on this, I can address this in a later video, so please leave comments if you're a little confused by it. We're going to be using Visual Studio, so I do have it set up here. As you can see over here on the right-hand side, I have it set up already with my part 1. I just named it part 1. That doesn't come included in the project. If you want to add something, just simply go to add, go to new item. Down here, you're going to name it whatever it is you're naming it. Again, I named it part 1. It's not going to know that it's assembly language automatically, so you need to put the .asm. Otherwise, you will not be able to run assembly language. It just won't know. It will keep running it as C++. And then make sure you save it to where it is you're trying to save it. So I have here started with the title. So we're going to start with our title. Mine's again part 1. We're going to do include Irvine library, so this way we have the library included, so we can do certain call functions and various other manipulations within the data. We have the data section and our code section, and then right here we have all of our main procedure already declared. And if you're not familiar with some of these things, again, please leave some comments in below. I do recommend checking out some YouTube videos online and reading some of the stuff on that Irvine library. There's a lot of good, useful information on there. So let's start with some of the very basic stuff. Let's go ahead and do some variables. So we'll be declaring some variables. We'll have them initialized to 12D. Let's see, variable 2. We'll have another one of those. We'll have it initialized, say, to 5 decimal, right? Now, I know that a lot of people who are familiar or starting to learn this know that these numbers right here are actually written as decimal here, but you can actually write it like this, and that's still decimal. It doesn't matter. It's good practice to have it there just so it's easier to read and you know for sure, and the program knows for sure what's going on. It just makes it much more readable and much better. Now, what I will say too is you could do a third variable, let's just say, or any variables, any number of variables, and you can do them uninitialized. So with this question mark here, this just says I have a variable. It's going to be involved in the process somewhere. I don't want to initialize because I don't want it to skew what it is that I'm trying to do. I want to make sure that it has the final result it's supposed to have. And so this basically just says, don't initialize it, but leave some space for it. So we'll go down here. We do have our registers. Now we do want to zero out some other registers that we're going to be using. And so I always recommend just moving into these things right now, some zeros, so this way it zeroes out that whole entire register, and you don't have to worry about there being a 1 or 2 in there or a million or some crazy number and throwing off everything that you're trying to do. Now, since these are byte size, which you could have done word, dword, quad word, you could have done any size that's available. But we went ahead and did byte just for for the heck of it. So what we'll do is we'll go ahead and move into AL, since that would be a byte size, and we'll go ahead and move into variable 1. Now, what I always recommend, always, just run your program just in case. It's only one line of code that's actually doing something for the most part, but you always want to be sure that it's actually able to run and that you're not messing it up. And it says no issues found here, 0 errors, 0 warnings, and we're ready. So that's good. So we're doing the right thing. So this means, and here, I'm going to show you how to do some comments, really easy. This starts a comment, too easy. Semicolon will start the comment. I put a couple of dashes or slashes, if you will, just to make sure that it's easier for me to find it and locate those comments amongst all the craziness that goes on, because when you start getting thousands of lines of code, it gets wild. It gets hard to read and hard to find things and understand what's going on. And if you do the comments as you go, it'll make it that much easier to troubleshoot. So in here, we have AL, the variable 1, so that means the AL register is equal to 12D. Too easy. So now we'll move into, let's say, BL, var variable 2, which means that BL is now equal to what? 5D. All right, too easy. Now what we can do a simple add. We can do add to AL, because what's on the left is what's being manipulated. I'm adding to my AL register what's inside of my BL register, and I'll put that over here. AL is now equal to AL plus BL registers. Really simple. So what that means, that AL should now have, I'll put it over here so this way you can see it. AL should now be equal to, what was AL before? 12. BL was 5, so it should be 17D. 17D. So let's go ahead and run this. We'll do a breakpoint. Actually, we'll do a breakpoint right here so we don't exit just yet, because I want to look at what is an AL just to make sure that it's actually working. And over here, as you can see, you can add a bunch of things to your watch list. Let me go ahead and delete some things off these watch lists. This is some stuff that I was working on before. Let's go ahead and look at AL specifically. And then let's look at BL specifically. All right, so as you can see, we have different numbers. And here we have 11.5, and if we step through, yep, so here it is, 17. So if you look here, we got 17 right here, and we got 5 right here for BL. So that means, you can ignore these, by the way, the types. Don't look at those. They're all sorts of weird. I wouldn't worry about it. They don't read properly here on Visual Studios. So as you can see, you got 17. If we wanted to, we could actually step through this, and we can watch this work its way through. And you could do it over here too. Let me put my flags just so we have flags too. These are all in memory. These are registers right here. So we're actually watching the registers. As you can see, everything in EAX is zeroed out. As you can see, EBX is not, and neither is ECX. Now, as we step through it, you'll see how they turn red. This just cleared out EBX. This command right here just cleared out EBX. Now we're stepping into ECX. Now ECX is cleared out, as you can see from this command. So following the yellow arrow, we're right here now. And variable 1 is now being moved into the AL register. As you can see down here, there's 0 inside the AL, 0 inside BL, which is, as you can see right here, 0 in the lower half, or lower portion of EAX, 0 in the lower portion of EBX. We'll step through there. We now have 12 inside of AL. We now have 12, which is C, in hexadecimal. All of this will be in hexadecimal. This over here will be much easier to read, which is why I add the watch list to make sure I'm actually understanding what the numbers are. Over here, 5, perfect, right inside of BL, and 5, and that's what that handled. Now, when we go to add, we simply add that, and what we get is we get 17, or 11 in hexadecimal. So we get 17 here inside of AL. Pretty simple, pretty straightforward. So that's cool. So now you learn that. So we went over that. So these are some of the reserved words here. It's like add, move, things like that. Those are reserved words. Multiply, subtract, increment, decrement. If I wanted to do, for instance, if I wanted to use the reserved word increment, I could always increment AL. Increment AL. So this increments the AL register. So now AL is equal to 18D. And again, we can just double check that by kind of stepping through it and watching our watch list here and our registers. 17 here, 17, so it's 11 a hex. We stepped into it, we're not at 18, we're not at 12 a hex. Perfect. So those are reserved words, really easy to manipulate, really easy to use. As far as labels goes, these are the labels. These are identifying your variables. They're labeling the variables. Again, these are the sizes here that are associated with your labels, and then these are the initialized values or uninitialized. So now we'll be looking at the TEXTEQU directive. This is a pretty cool little thing. I really like the TEXTEQU directive. It has a lot going on, but at the exact same time, it's pretty simple. So let's look at a really good example, really simple example, which, let me pull this up really quick. All right, let's take this breakpoint off. We'll just be going ahead and doing a really easy TEXTEQU. So we'll say move. Let's say you accidentally put in the word move, literally the word move. Instead of putting MOV, you just have to put MOV, right? So what we'll do is we'll do a TEXTEQU directive that says, when I put this in on accident, correct it to this. So what I'm doing is I'm correcting it to move. So if I actually put move here, this should work because this TEXTEQ will override it. As long as I have it in the right spot. Let's make sure. Let's run this real quick. We're here. I put move. So right now it should be, yep, and there it goes. And now it equals 12, which is C in hex, and it works. So as you can see, that works. And again, I always test everything as you go through here. Otherwise, you're going to go crazy trying to troubleshoot this. Okay, so that's lesson 1. Tomorrow we'll be covering some different items on the list. And if you feel that this was of any benefit, if you enjoyed this at all, or you think that somebody else might benefit from this, please feel free to share, like it, follow us, and obviously check us out at techtoport.com. Thank you very much and have a great day coding.